All right, so we are at the top of the hour. Good morning, everyone. Welcome to this week's edition of the Long Coffee Break. My name's Austin Whiteley. I'm a cell engineer here at Long out of our Fort Collins office. This week, we're joined by Art Bordeth from Friedrich. He's here to give us a general overview of the Friedrich product offerings, talk about the refrigerant updates that meet the new DOE requirements, as well as give us an update on the VRP VTAC product line. Art, thanks for joining us today.
Great.
Please
Thanks,
take it
Austin.
away.
Great. Thanks, Austin. I appreciate it. Appreciate the opportunity. And hello to everyone else on the call. And I'll try to be as succinct as possible and hopefully impart some useful information to you. Great. So I actually liked the opening slide a whole lot better than the generic one I put up. So thanks for flipping through that, Austin. You're pretty good at that. Thanks. Well, I'd like to start with a photograph of an actual project that we did. This is obviously a project. You can tell by the gentleman sitting on the couch all alone and reading his phone with a mask on, so you can kind of dates it. This was mid to late 2020, and it's a mid-rise condominium project in our nation's capital, Washington, D.C., as you can see in the background. What's noteworthy about this photograph, and we'll come back to this here later in the presentation, but what's noteworthy about it is that besides the guy sitting all alone with a mask, is that what you don't see in this photograph. So what you don't see is you don't see a condenser farm. You don't see all the things, you don't see DOAS, you don't see that sort of stuff. And there's a reason for that. And we are responsible for being able to clean up these roofs. The owners love the idea that with our VRP product, you can clean up some of the stuff on the roof. And I'll tell you why later. Mainly we'll go into a little bit deeper, but let's get on with the product presentation. We'll come back to that. So as you may be aware, we've been making PTACs for quite some time, probably about 40 years now. And we have a three-tiered product line. We have a good, better, best, if you will, offering. We start with our Select, which is just a basic PTAC. About 12 years ago, our Zone Air Select was actually our premium product. So it is not a cheap knockoff, or you're not sacrificing a lot. It's just that it's not as efficient. It doesn't bring in fresh air and have some of the other features. Then we go to the Zone Air Premier, which is available in heat pump or electric heat. And it has a rotary compressor, so it's a little more efficient. And it is actually the quietest PTAC on the market. And then there's our Fresh Air PTAC, which again has an inverter compressor and an inverter fan, variable speed unit. And it is also pretty quiet, but it's about 2 decibels louder, hardly noticeable. But it is a very popular unit simply because it brings in fresh air and mixes it into the room to keep the room fresh. What we're going to talk most about today, though, is our vertical product. We've got 2 products, our VertiPack product, which we've had for about 15 years. We've just made some major changes and redesigned that product. We'll talk about that in a minute. And we'll spend more of our time talking about our premier product, which is VRP. It's a variable refrigerant packaged unit. So we'll get on with it. So VRP is kind of solves a lot of problems for some designers and some owners. It is an inverter-driven compressor, as I mentioned on the other product. It can bring in fresh air. It brings you the efficiencies of a VRF system, but with the ease of a VTAC. You just don't need lots of other things. You can greatly downsize your DOAS. We'll take care of the fresh air requirements in the space we're conditioning, and provide some ductwork savings and some other installation savings as well. So just a nice extra benefit with VRP. So when you look about a project and you're kind of analyzing things, what do we need to apply and how do we apply it? And you look at the cost versus complexity versus performance issues that you're dealing with. You can start with something on a design as something as simple as a PTAC. You can move up to a little more complex, but more gives a better look because the product's in a closet. A VTAC on the other side of the coin, it gets much more expensive. You can do a full-blown VRF system or a 4-pipe system. Obviously, those second two are hugely, the price and the cost of that project hugely increased because all the piping, all the controls, all the extra installation. Well, VRP kind of is the sweet spot between very simple and very complex. It gives you the performance and the economy of the larger systems, but it comes in at a cost closer to the products on the left, the more simple solutions. Excuse me. So when you look at performance-wise, I'm going to, for sake of time, we'll talk about our 1-ton unit. It's some of its performance characteristics. You're going to get 1 ton, 12,000 BTUs all day, every day. But because of the variable speed compressor and the variable speed fan, on light part load days, when you don't have a lot of demand, that machine will turn down and provide as low as 5,400 BTUs of cooling. Conversely, on a heavy load day, we can blow past the 1-ton rating on cooling, and we can provide up to 16,000 BTUs. So it saves you from moving into a larger unit of someone else or of some other variety, but it gives you that nice variety, economy, and performance with the inverter and the variable speed nature of the product. Gives you a solid 20 SEER. And if you see on the heating performance side, it's very similar. You can turn that 1-ton unit down to about 4,000 BTUs of heating, and you can overdrive the compressor with the inverter technology to about 14,000 and still get 3.4 COP. So pretty nice performance and solves a lot of issues as far as sizing and gaps. So all the pieces of the puzzle kind of come together with VRP. So the two primary things you need, you got to have a way of effectively cooling, effectively heating, and doing so efficiently. We have a excellent humidity control. We'll talk about that a little bit more. And we have the ability to bring in fresh air and condition it, filter it in the system, in the unit. So you kind of get all pieces of the puzzle come together. I'd like to stop and talk about startup, because a lot of the contractors are concerned, a lot of owners, how do we do startup? Well, we will provide 2 site visits from a factory technician should the owner choose or the customer choose to do factory startup. It'll be 1 mock-up visit, and it'll be with the rep and the installing contractor. We'll have a startup visit with the installation team and walk through that process. And make sure that they followed the mock-up we did in the previous visit carefully, and kind of make sure that everything's ready to be started up. And if not, there's some anomalies we corrected at that point in time. The benefit from a factory startup is that it's an additional 1-year parts warranty at no extra cost. And just to answer any questions about refrigerant, we are in October of this year, we're moving across all products with Friedrich to R32. So when you look at heat pump performance, in Colorado, you've got some areas can get pretty cold. So it may be kind of interesting. So with a standard heat pump type of product, you see the orange line, you get about 40 degrees, 38 degrees, somewhere in that range. Then the unit will decide it can't efficiently heat with heat pump, and it changes over to resistance heat. And you see the cost just jump up and stay at that level all the way down the temperature range. But with VRP, with the blue line, as you can see, we hit 38, 40 degrees, and we're still trucking along under heat pump operation. And we can effectively provide heat pump service and comfort down to between 0 and 5 above. So we comply with ASHRAE 62.1 commercial and 62.2 residential IAQ building codes. We do that with our fresh air system. The fresh air system is a fan module that actually will bring in, you can see in the drawing, we're bringing in outdoor air in the back of the unit mainly for condenser air to cool the condenser, but we're trailing off a bit of that and going up into the module, as you see just above that chassis. And we're filtering it at MERV 8. There's a fan and damper situation there that, by the way, closes when it's not in operation. And we pull that air, condition it, mix it with return air, and put conditioned air, filtered conditioned air back into the space. We also, how do we do dehumidification? Well, pretty much the same way that engineers have been doing it for a long time, subcool and reheat. And you can see in the photograph there, you can see the evaporator coil. And then what we're doing, we're wringing out the moisture, we're subcooling that air, drying it out. And then under number 2 there, right next to it is attached our small reheat coil. So because it's super cooled air at that point, we need to heat it back up 10 to 12 degrees to make sure it's a comfortable cold air being discharged into the space. Very effective in humidity control using hot gas reheat. There are also some pretty significant installation advantages when you look at, say, a 4-pipe system or a VRF. Building on the left, you see all the piping, you see all of the work, the duct work, the controls, and the building on the right, you have an individual VRP unit in each space. If you lose one of those condensers on the left or just one circuit of the condenser, a number of people will be affected and dissatisfied. If you lose one VRP unit, the only dissatisfied person or occupant is going to be just in that one room. So we're mitigating that the amount of trouble that you're going to have. So a lot of different choices you have when you design a system, everything from water source heat pump, maybe 4-pipe chiller, very complex. You see all the red check marks there of all the things, components, other equipment you need for those systems. VRF gets a little simpler. You can go that. Still need full DOAS in all 3 of those first. And then VRP. You need the unit itself and you need a mechanical closet, and we can provide some of that fresh outdoor air, at least into that space. So you don't need full DOAS. So the cost of installation, much, much less than some of the other larger, more complex systems. So this is just this is an estimate that a customer of ours did when we introduced them to VRP. It's been a couple of years ago, but this is a large developer in the Southeast. They did this estimate and then showed it to us. They actually blocked off their logo. That's the black in the upper left-hand corner. But to do identical condominium spaces with VRF, they came up for the entire mechanical cost for that individual condominium was $35,000. To do that same space with VRP, $22,000. Huge difference. So you save about a third in installation costs, which is passed directly to the owner. That's all I've got. Thank you very much for listening, and I'd be happy to discuss these things with you. And Austin and his team do a great job with VRP. So good luck. And if they can't answer your questions, they'll just get in touch with me and we'll get you squared away. So thank you for your time.
Thank you, Art. I appreciate you taking the time to give us this quick presentation and give us some very useful information. Join us next week with Nick Bryant. He'll be here to discuss the code impacts that we're having with the new A2L refrigerants. Please join us next week and we'll talk to you soon. Thank you.